In the last video, I looked at the what I call the fundamental trigonometric identities, and we kind of touched on how we can use these to prove other identities. But anyway, here they are. I'll go through them slowly. You can pause the video in case you want to look at these. So we have the quotient identities given there, the reciprocal identities, the Pythagorean identities, and then even and odd identities. So we talked about the fact that the cosine and secant function were even, and the other four are odd. So we want to use these identities to prove or verify that these are identities. So the first one we have cosecant of x times tangent of x is equal to secant of x. Okay, so we're going to use the basic or fundamental identities along with basic definitions. In this case, it's going to be mainly the identities. And to verify an identity or to prove an identity, the general procedure is to start with one side and show how you get the other side. It doesn't matter whether you start with the left side or the right side, but never start with the equality, because if you just start multiplying both sides by something, you're assuming already that the identity is true. So you're trying to prove it. Okay, so for the proof, I want to prove or show or verify that cosecant times tangent of x is equal to secant of x. Okay. So I start, in this case, I'm going to start with the left side. And generally, there are exceptions, but in general, you want to start off with a more complex side and show how you get the simpler side. Generally, okay. Sometimes the right and the left side could be pretty much similar, so it doesn't really matter. But if you see something or you get a hint as to what to do, then you take whatever side looks good for you. So let's start off. Okay, I want to get secant out of this. So what do I know? I know that cosecant of x is 1 over sine of x. So you kind of get an idea. I want to start off with secant of x. So keep in mind that if I'm able to generate or get 1 over cosine, I know that 1 over cosine is secant of x. Okay, so keep that in mind. Okay, so it's you look at the big picture here. Okay. Now tangent of x is sine of x over cosine of x. Okay. So this is just like multiplying algebraic expressions. You're allowed to multiply through, cancel like factors, and so forth. So notice here, sine of x and sine of x, once in the numerator, once in the denominator, those will cancel. What's left on top? 1 times 1, we get 1. At the bottom we have 1 times cosine of x, that's cosine of x. And then of course we know from the basic identities that went through last time and I showed you today that 1 over cosine is secant. Okay. So because I know that secant of x is 1 over cosine, I know that if I can come up with 1 over cosine, I've got the answer. Okay. So that shows it. Okay. So again, we start with one side and then apply your basic identities, fundamental identities, and show how you get the other side. Again, start either with the left or the right, but generally you start with a more complicated side and show how you get the other side. Okay, let's cancel this out. This one again, we have two terms on the left side and two terms on the right side, so they're kind of close. But I can see that the left side I have difference of squares. On the right side, I also have difference of squares. Well, I'll take it back. I don't have difference of squares on the right side. I do have it on the left side. So I have difference of squares here. So I'm going to start with the left side because I know I can factor. So generally, you write out the side we're working with. So cosine squared x, or I should say cosine to the fourth of x minus sine to the fourth of x is equal to, okay, so my objective is from this I want to get 1 minus 2 sine squared x. Okay, because I have difference of squares here, I'm going to factor this out into cosine squared x minus sine squared x. So that's going to be one factor. Then this one then will be cosine squared x plus sine squared x. Okay. But from the basic or fundamental identities, I know that cosine squared of x plus sine squared of x is 1. So this simplifies to 1. Okay. So I'm just going to extend this over here. So it's okay. This then is going to equal to 1 times this. So that's going to give me cosine squared x minus sine squared x. Okay, so now so far we've got cosine squared x minus sine squared x. Now what do I want to get? I want to get 1 minus 2 sine squared x. Okay, so I've got a sine squared here. So that would suggest then that I would want to get some kind of substitution for cosine squared. Okay, well, from your basic identities, we know that cosine squared x plus sine squared x is equal to 1. So if I solve this for cosine squared, this would tell me then that cosine squared x is equal to 1 minus sine squared x. Okay, now making the substitution for cosine squared, putting this right here where the cosine squared x is, would give me 1 minus, and then minus sine squared, and a minus sine squared is minus 2. Sine squared x. And that's what we're trying to get. Okay. So that proves that identity. Okay, let's clear this. Look at the next one. We're trying to show that 1 plus tangent x over 1 plus cotangent x is equal to tangent x. Okay. And it should be clear that the left side is more complex than the right side, so I'm going to start with the left side. So I'm going to start off and say, okay, 1 plus tangent x. So you write down the side you're starting with. 1 plus tangent x over 1 plus cotangent x. And we're trying to show that this is the same thing as tangent x. Okay, so you use a little bit of common sense here. We want to come up with tangent of x, okay, because that's what we have on the right side. The left side has 1 plus tangent x on top and 1 plus cotangent x on the bottom. So since we want to come up with tangent, let's try to get everything in terms of tangent and then try to simplify. Okay, so all I'm going to do here is I'm going to just rewrite the same thing. Except I'm going to replace, using the basic or fundamental identities, cotangent of x is 1 over tangent of x. Okay. Now, just treat this just like an algebraic expression. We're going to simplify it. So generally multiply by the LCD of these. Okay, so I'm going to multiply the top and the bottom by tangent x in order to simplify this complex fraction. So multiplying the top by tangent of x, but I'm going to leave it as a product here, okay, to get a better look at it. So tangent x is 1 plus tangent x. Okay, and then multiply the bottom by tangent x. So tangent x times 1 is tangent x. And then tangent x times 1 over tangent. The tangents cancel out and I get 1. Okay. So I have on top tangent of x and then times 1 plus tangent of x. So that's the factor there. And then on the bottom I have tangent of x plus 1. Well, tangent of x plus 1 is the same thing as 1 plus tangent of x. So this factor here will cancel with that one right there. What's left? Tangent of x. Okay, so that's your proof. Okay, so always look at the big picture. What are you trying to wind up with? In this case, we're trying to get the tangent x. So I converted everything on the left side in terms of tangent x, simplified, and it just came out. But always looking to see if something's going to cancel to make the solution a little bit simpler. Clear this? Okay. We have sine x over 1 plus cosine x plus 1 plus cosine x over sine x is equal to 2 cosecant of x. Again, the left side is more complicated, so we take the more complicated. So I have sine of x over 1 plus cosine of x, starting with the left side, plus 1 plus cosine x over sine of x. Okay, so we're trying to get 2 cosecant of x. 2 cosecant of x. Okay, well, if I get 2 over sine of x, that's the same thing, because cosecant of x is 1 over sine. Okay, so now treat this just like an algebraic expression, so we're going to combine this, so we need to find the LCD. So the LCD is going to be this times this. Okay, so that's going to go on the bottom. So it's going to be 1 plus cosine x times sine of x. And then I'm going to leave it in the simplest way that I can. So I could multiply this out, but sometimes things are going to factor out, so it's better if you leave it in factored form. Okay. Now on top, basically it's going to be this times this, and this times this, this times this. Okay. Because to get the LCD, I'm going to multiply the top and the bottom by sine of x here. And over here, I have to multiply by 1 plus cosine x, top and the bottom. So it's the same thing as cross multiplying here. Okay. Now here I do want to multiply because I'm getting quite a few terms. So I'm going to go sine x times sine x is sine squared x. And then this product right there is 1 plus cosine x times 1 plus cosine x. That's going to be, that's kind of like if you had 1 plus x times 1 plus x. That's 1 plus 2x plus x squared. So this will give me 1 plus 2 cosine x plus cosine squared x. Okay. But sine squared plus cosine squared, that's one of your Pythagorean identities. Sine squared of x plus cosine squared of x, that's 1. So these two terms add up to 1. And then there's a 1 right there. So that's going to give me 2 plus 2 cosine x. Okay, so again, always looking ahead. I said that to get 2 cosecant of x, I can get 2 over sine of x, and that's the same thing. Okay, so looking ahead here, I can see that you can factor the top mainly by taking out a 2. Here at this. On the bottom, we have 1 plus cosine x sine of x. Okay, so as I mentioned to you last time, to be successful in trigonometry, you need a good foundation in algebra. If you can do algebra, you're pretty good at algebra, you'll be able to do trigonometry. Because now look, these are not like factors that will cancel out. So this comes out to 2 over sine of x. And I could actually break this up into 2 just to make sure you see it. this is the same thing as 2 times 1 over sine of x. But 1 over sine of x is 2 cosecant of x. Okay, so this is just, you can just say this is equal to 2 cosecant. Of x. Okay. So these identities are kind of like a puzzle. Okay. Put things together. You know what the answer is. That's the thing about proving identities. You always know what the answer is because you got to start with one side and you got to get the other side. Okay. But make sure you don't just start doing. I've had students who start proving identities and they just put a bunch of stuff that's not readable, and all of a sudden they put down the other side. Okay, say, okay, I got it. But that's not the way it works. You have to go through the steps and show it. Okay. All right. I'll take care. We'll see you in the next video. Thanks for watching.